Alright, so in this video we're going to be talking about geometric series. A geometric series is obtained by adding the series of a geometric sequence together. And the geometric sequence is generated when you multiply by a common ratio each time. Alright, so this is your summation notation. You have sigma going from I equals 1 up to n. Remember that this represents the first number that you substitute into your formula, and then n is the last number that you will be substituting into your formula. And so this is just a notation on how to find your sum for a geometric series. This is the actual formula that you will be using to find the sum of your geometric series. Your sum is going to equal a sub 1, which is your first term, times 1 minus your common ratio raised to the n power, which is the number of terms, divided by 1 minus your common ratio. And this just tells you what each of those variables represent. All right, so with this particular problem, we're going to find the sum, and we've got our notation here. So the sum is equal to a sub 1, which is our first term, of negative 3. And we can find that first term two different ways. One way is thinking about our notation is a sub 1 times r raised to the n minus 1. So this is your a sub 1, your first term. Another way of thinking about this is we can substitute 1, your lower bound here, substitute 1 in for n. 1 minus 1 is 0. Any number to the 0 power is 1. And then 1 times negative 3 is negative 3. So that's the other way we can generate that. That is probably a better way of generating this, because sometimes your series may not start with n equals 1. Your series may start with n equals 5 or 10, in which case this would not be your first term. Your first term, you would plug that number in, and that would generate your first term of that particular series. All right, so then we have parentheses. We're going to have 1 minus r, which in this case is 1/2, raised to the n power, and n is the number of terms. Since we're starting at 1 and going up to 4, that means we have 4 terms here, over 1 minus 1/2. All right, so I'm going to work this out algebraically. You can also use a calculator to find this. Just simplifying what we have in the parentheses here, 1/2 raised to the 4th power would be 1 over 16 over, and then 1 minus 1/2 is 1/2. All right, so 1 minus 1/16 would be 16/16 minus 1/16, and that will give us 15/16 over 1/2, which is negative 3. And when you divide by a fraction, you multiply by its reciprocal. Now the 2 and the 16, those can reduce, and that's going to give us negative 3 times 15 over 8, which is negative 45 over 8. That would be our sum for this particular series. All right, what I want you to do now is write this problem down, pause the video, and then work the problem out on your own, and then unpause the video, and then you can see your result and compare it to what the answer is. So go ahead and pause the video at this time. All right, so this is your solution. Your first term is 81 from right here. Also, by putting 1 into n, you're going to get 81 as well. Your common ratio is 2/3. and the number of terms is 5 terms. Going from 1 up to 5, you can subtract these and add 1 to that. That would give you their number of terms that you have. All right, so then just working this out, 2/3 raised to the 5th power means 2 to the 5th power, which is 32, and 3 to the 5th power, which is 243. So this would be 243 over 243 minus 32 over 43, which is this. And then dividing by 1/3, you multiply by 3 over 1. You can cross-reduce here. And then that gives you 211 over 81, which the 81s will cancel out, leaving you with 211 as your solution. All right, so the next problem says express the series in sigma notation and find the sum. So the first thing we're going to do is express this using sigma notation. All right, so we're going to have this starting at n equals 1, and there are 7 terms here, so we're going to take this up to 7. A sub 1 is 81 over 64. Your common ratio, we can get a number of different ways. Your common ratio you get by taking your term, multiplying it by r to get the next number, which means if you want to find the ratio, the common ratio, you can take this number and divide it by the previous number. Just to write that out and show you what I'm talking about, if you take the first term and multiply it by r, that would give you the second term. And so that means r would equal a sub 2 divided by a sub 1. Now that works not just for the first and second term, it can work for any pair of terms that are next to each other in this series. So you would take any term and divide it by the term that's right before it. Now we could do 27 over 16 divided by 81 over 64. That will generate our common ratio. However, there are an easier pair of numbers to use. That would be 4 and 3. If you take the 4, divide it by the previous number, that gives you 4/3 for your common ratio, r. And we're going to raise that to the n minus 1 power. So that is our sigma notation for this. The sum, if we plug everything into our formula, is the first term of 81 over 64 multiplied by 1 minus your common ratio of 4/3 raised to the 7th power, because we have 7 terms here, over 1 minus 4/3. All right, so I would just use a calculator on finding this. Comes out to 141,197 over 5,184. All right, so we're going to do like we did before. I want you to pause the video, write the problem down, and then work it out. And then when you're done, unpause the video and check your solution. So go ahead and pause the video at this time. All right, so here is your sigma notation for the sum. You have 6 terms here, so you're starting at n equals 1 to 6. 8 is your first term. Your common ratio is 3/2, which you can get by taking the 12 and putting it over 8. So you're taking any number and dividing it by the previous number, and that reduces to 3/2, and then raised to the n minus 1. Substituting everything into your formula, you have your first term, your common ratio, the number of terms up here, and then simplifies down to 665 over 4. All right, so for our next problem, it says what is a sub 1 for the geometric series with 5 terms whose common ratio is 1/3 and whose sum is 968. All right, so we're going to take our 968 over 9, set that equal to our sum formula, which is a sub 1 times 1 minus your common ratio, which is 1/3, raised to the n power, which n is your number of terms, and we have 5 here. And all of this is over 1 minus 1/3. All right, so working out the arithmetic here, and again, you can probably use a calculator just as well. But the arithmetic is fun, so let's go ahead and do this. So 1 to the 5th power is 1. 3 to the 5th power is 243. 1 minus 1/3 is 2/3. All right, so we have 968 over 9 equals a sub 1. Now let's simplify this. You're going to have 243 over 243 minus 1 over 43, which will give us 242 over 243. Then we're dividing that by 2/3, which means multiply by 3/2. All right, so we can cross-reduce a little bit here and simplify some things. 3 goes into 3 once, and here 81 times. 2 goes into here once, and here 121 times. All right, so we now have 968 over 9 equals a sub 1 times 121 over 81. And we can multiply by 81 over 121, multiply by the reciprocal to solve this. So multiplying by 81 over 121. And that's going to give us a sub 1 is equal to 72 when you reduce everything here. And those cancel and those cancel. All right, so go ahead and take a little time to write this problem down, pause the video, write the problem down and work it out, and then when you are finished, you can unpause and check your solution. All right, welcome back. You can check your answer here. I've just gone through all of the arithmetic on working this problem out. It's worked out the same way as the previous problem, and your solution for the first term comes out to be a sub 1 is equal to 160.